Today we're going to be talking about Creo for industrial design. I'm Joshua Fontana. So for the agenda today, we'll do a little introduction about Foundry Systems, and then I'll go over a demonstration for Creo for industrial design, and afterwards we'll have a Q&A session if anybody has any questions. So you'll notice in your webinar dialog box there's a questions section there, so you can type in any questions that you have throughout, and then we'll answer them at the end. So about me, I'm Joshua Fontana. I've been with Foundry Systems as an application engineer for about 3 years now. I have a bachelor's in mechanical engineering technology and associates in mechanical drafting and design. I've been a team leader in lean implementation in a couple different companies. And I have about 6 years of mechanical design experience. So I have a wide background from engineering to design to drafting. So I've been implemented in a lot of different cases. So about Foundry Systems. Foundry Systems is a technology leader whose partners include PTC, Solid Thinking, e.t.c, Autodesk, and other tech companies. We're the 16th fastest growing private company in the greater Cleveland area, and some of our capabilities include product lifecycle management, data management, CAD design and consulting, simulation, and product development. And as you can see here, there's a vast array of companies that we work with from all over. Some of Foundry Systems accolades include industrial awards from the Inc. 5000 and the Weatherhead 100, and some other accreditations from Winchell Certified Implementer, and we're a PTC Preferred Service Provider and a PTC Certified Training Partner. So we can handle any of your training or service needs. So some of our solutions offered at Foundry Systems include PTC products, a full range of PTC products, also Solid Thinking, Autodesk, e.t.c, and e.t.c. Okay, so any further information that you need about any of those subjects, any technical questions, you can consult me, Joshua Fontana, at my email address there. Or if you have any sales-related questions, you can contact Carrie Tanko with the email address there. So we'll go into Creo Parametric now and show you what I have planned for today. So today we're going to go over some e.t.c, and then for this bronze shaver, as you can see here. So here's a shaver. So we're going to be utilizing Creo Parametric 3.0 for the interactive surface design extension. So e.t.c combines industrial leading freeform surfacing tools within the parametric environment of Creo Parametric. So in today's demo, we'll provide with an overview of e.t.c capabilities by modeling the external surfaces of this electric shaver. Okay, so here is the initial, what we're going to start off with. So it already has the head and some internal components, and we need to create the free form body. So we have a part we already had created in here that we're going to go ahead and open, that we have open already, with some reference geometry for creating that the freeform surfaces. So here we can reference, we had some artists sketch up some images of how they want the shaver to look like. So we can easily put those inside the Creo Parametric session, so we can use those for reference. So now we can go into e.t.c and start creating curves. So first I'm going to activate a plane to sketch on, to put my curves onto. Okay, so my first curve here is going to be the upper curve to connect the front and the back. So I'm going to place this curve and attach it to the other reference geometry here. And if I take a look over here, I can easily snap the curve to those references that are already there. So right now, this is a free curve, so you'll see that it's going in 3 space in and out of the plane, which is undesirable. So what I'm going to do is designate this to be a planar curve. So I can select planar and then let me go in and edit this, and then say planar and the front curve, and you'll notice that it snaps right to that front active plane. Okay, so that looks good. We're going to go ahead and manipulate some of this curve so it conforms more to the image. So we can take the draggers, the tangency draggers, and manipulate them. This one I'm going to specify to be normal to a specific surface and that we already have a datum plane set up for, and it snaps right to place. Then you can increase or decrease the trajectory tangencies there. And then you can also, up at the top here in the dashboard, increase the degree of the curve, and then to fine-tune the shape of your curve a bit. So we can manipulate these until we have something closer to the design of the sketch provided by the artist. So that looks pretty close right there. So we'll say OK and accept that. So we'll go ahead and place another curve down at the bottom here. We'll snap that again to the references provided, and a couple locations here to accommodate for this curvature in the handle. And again, we'll come over here and snap that right to the reference. Okay, so that looks pretty good. And again, I forgot to change it to a planar curve, which that's okay. We can always manipulate that and say planar, and then where you want to snap it to, and that will go right to the location. We're going to have to manipulate some of these points that we put in though, which is okay. You can easily select them and drag them about. And again, this first point here, we need to make sure its tangency is normal to the surface here. So we'll select that to be normal. And again, we're going to move these a little bit so the curve matches the shape a little better. And then come back over here and change the tangency of that curve. Okay, so that's looking pretty good. Zero this in a little bit. So you can play with these curves to get the right shape that you want to. And it's really easy to do. Okay, so that's two of the curves for our shaver handle. So next we need some more curves and be able to generate the surfaces. So first we're going to create another curve that goes along the edge here. So again, we'll create a curve and then snap that right to this line, and this one's going to be a free curve because this one's going to be going at the center, so we want it to go out of plane. And here we're going to snap that also to the existing reference. So what's nice about e.t.c is that you can utilize 4 views to generate your curves, and you can work in all of them. Oop, let's undo that. Okay, so here our curve is just going from A to B. So here I'm going to, in this view, I'm going to specify this point to again be normal to the reference datum. Okay. And I also want to put another point in here that I can control. So I can easily do that and then move that point. And you'll see up here in the other view that the point happens to be within the body. So we're going to pull that out. Since it's a free curve, you can easily manipulate that in all these views. So the point down here needs some more curvature, so we can easily change that by dragging the handle out in this top view. And also you notice that it's not following the image in the other view, so we can drag it in that view also. Okay, so that's starting to look like the way we want it to. Okay, so if we need more control points, we can always increase the degree here to refine that a little better. Okay, so that looks pretty good. Again, we can go and manipulate this in all views here to refine that. So that looks pretty good there. I could take a look in my ISO view and see that those 3 curves are starting to form the what I need to make the surfaces. So down here at the end, I need another curve to connect these 3 curves together, so I have an end to my surface feature. So I'll go over here and create another curve while I'm over, and I'll just snap it right to these existing curves. Okay, but we see it doesn't really match up with the existing geometry we have here. So we're going to go ahead and add some other points in here that we can manipulate so it lines up with the existing geometry. So what's nice is that we can see how this is out of plane. We can just take this one point and snap it right to that reference. So even if it's a curve and it's out of plane, you can snap it right there so the geometry is accurate. I'll do the same with this other point. So that looks pretty good. So now we're done with this feature here. We can exit the 4 views and wait for. So we're pretty close there. So I had a technical difficulty. I'll have to reopen up Creo Parametric real quick here. Okay, so we're back up and running. Let me get those files up and running again. So if I see what we have here, so here's the shaver body. Okay. So let's see if I can put this back together real quick and create some curves. Oh, better yet, let me go back and see if I have, yeah, okay, so I'll go in here and kind of show you the end result and then work it backwards. So I can do that fairly easy. Let me turn off these images. Open this here. Okay, sorry about that. So let me turn off these images. Okay, that one. This one I would like to hide. Hide all of these. Okay. So let me get rid of some of these features. And go into the style feature. And just delete some of these. There, now we're back to where we were pretty much. Okay, let me get rid of these curves. Okay, great. So now we're back to where we were. Sorry about that. So we have our 4 curves here. We need to create some other curves in between here to reference so we can manipulate the shape a little better. So here we're going to create another curve, and we're going to set the plane to reference. Has to be a planar curve and able to reference it. So we'll go to the reference collector and set the plane right there. And that's a little bit far away, so we'll move it a little bit further. You'll notice that this plane is normal to the reference curve. There we go. So that looks pretty good. So now what we can do is easily create a curve that connects these 3 curves together. So I'll go ahead, notice that it automatically snaps to this point here because this curve intersects the active plane. So that makes for easy curve creation, as you can see there. So that looks pretty good. and I can come back and edit the tangencies of these points. I want this one to be normal to the front. Same with this guy here. I'm going to change that to be normal to the front. Okay, so now that I have that, I can easily copy this curve and then drag it downward. You'll notice that all these points stay connected to the curve as it gets dragged down. Okay, so I have this maybe a little bit further, so I'm going to utilize some of these existing sketches for references. Okay, so now I'm going to go ahead and create a surface feature. So with e.t.c, you can select the surfaces in pretty much any order and create those high curvature surfaces that you can see here. So it's very easy to utilize. So we see that these curves here aren't really being utilized right now. So the curvature goes outside of the bounds of these curves that we would like the surface to lie on. So that would really be an internal curve. So we'll go ahead and select those so they lie down on top of those curves. So that looks pretty good. Okay, so we're also going to check the curvature here just to see what it looks like whenever it's all done. So you can visually mirror this, the surfaces, and I can do that here and just select the reference for mirroring, and you'll see that it's starting to look pretty good. So the curvature looks nice here within this mirror. Okay, so next I can create these bottom surfaces just as easy. So we'll select the surface here, and then these 4 curves that I created earlier. You notice it dynamically mirrors that over just visually. So that looks pretty good. We'll accept that. And then again over here, we can fill this gap in with the surface by selecting those reference curves. Now you see those little arrows by all the tangencies of the surfaces is where you can manipulate whether it's a position tangent curvature or a draft tangency. So you can increase or decrease the amount of curvature there. Okay, so that looks pretty good. So this is really starting to come together. But we do realize there is another feature here. Okay, so we'll go ahead and unhide this. So we need to be able to have a little scoop in here for this button. Okay, so we need a little relief in this section for that. So we can go in and utilize e.t.c for that. So we're going to get rid of the visual mirror here, and then make another surface that comes down and scoops out this portion. So we notice we have some curves, parametric curves down here that we can utilize to trim some of these surfaces. So what we're going to do is drop these curves on the existing surfaces. Okay, so we see those get dropped onto this curve, and then we can utilize those curves to trim them. So we can easily trim away the surface within that region. Okay, so that looks pretty good. So now we need to create some geometry, some surfaces to represent that scoop. Okay, so here we're going to place a curve, the free curve, and we would like to go from here to a little beyond where we want to utilize the surface, because we're going to end up trimming some of that away, and that's called the overbuild method. You can, build some of your surfaces and curves a little bit bigger than what you need to, and then trim them away. So that looks good right there, except we would like to change the tangency here a little bit, so it is tangent to the existing curve there. So that looks good. And then we can make a surface out of that existing curve and then utilize the existing edge here for a cross curve. So that creates our downward swooping curve or surface. And we have some other geometry down here that we could easily drop onto the surface that we just created, and then do the same trimming process as before. Except this time we're going to delete this outside portion, so we can put another curve and surface in there to connect them together. Okay, so that's starting to look pretty good. So let's go ahead and put another curve in there. And again, we can snap that right to this existing geometry. And then afterwards, manipulate the tangencies of that curve. So that looks good. We'll accept that. And then all we have to do is generate that surface. So we go up here at e.t.c and select the boundaries of that surface. And we'll see it generates that nice swooping surface for us. So now that we have all these surfaces, it looks pretty good. We can go ahead and exit out of e.t.c. And it looks like we're missing a patch up here. So we'll go back in real quick. Okay. So that looks good. So afterwards, we can go ahead and do a mirror those surfaces over to create the entire body here, and then merge them together afterwards. So it's all one surface. And then we'll take a look at the top assembly and see how it ends up with the rest of the geometry in there. So we can see the shaver head connected to it, of course the button, and the receptacle for the electric hookup or the charger. So that looks pretty good. Afterwards, we can utilize this in any of our other Creo apps. If you use it for making your drawings, you can use those surfaces for your machine purposes also in your manufacturing systems. So if you want to use them for your NC codes, you can easily reference those for that also. So again, this was e.t.c. And let me put up the slide again with the contact information. So if you have any other questions, let me check if there's any questions in the question box here. Go ahead and type in your questions there in the GoToWebinar. And I'll see if I can answer them for you. Okay, so if you guys have any questions, you can go to the GoToWebinar dialog box and type in any questions that you have there. If it's about anything about e.t.c. or Foundry Systems or anything of that nature. All right, well, it looks like there's not any questions. So again, if you have any further questions about technical questions, go ahead and contact me, or sales questions, you can contact Carrie Tanko. Thank you for your time, and have a good day.